Hello, Krishna. Hello, Kirtan. Hello, Kirtan. I'm audible.
Yes, sir.
Okay. Kirtan, in the last class, we discussed about the combination of registers, right?
Yes, sir.
Okay. So, two major combinations were there, series and parallel, right? Out of these two, which we discussed in the last class? Hello, Kirtan. Hello, Kirtan. Out of these two, which one we discussed in the last class? Okay, both I think we discussed it. Okay, do we had a discussion of the formula of both of them? I actually forgot like what we discussed. I'll just give you a circuit, okay? I'm giving one circuit case. Now let's try to solve it. Okay, before this, I'll just give you a direct overview. Series is basically a resistance kept being chain form, you can see, of series. How it will be like this thing, okay? R1, R2, R3. The terminal of one resistance will be connected to terminal of another resistor, and the terminal of other resistor will be connected to third resistor, okay? If it again comes back to the same resistor, like other terminal, both of the terminals are common for two resistors, so it will be in the parallel combination. Okay? In parallel, what happens? Terminals of resistors are terminal of two resistors are joined together, joined to each other. What does this mean? This is one resistor, terminal one, terminal two. This is another resistor, so repeat. Terminal of these two resistors are connected. This terminal is connected. If I have third resistor, if I want to make it in the parallel, so I'll be connecting this terminal to this to this. Okay? So you can say this is in parallel with this is parallel with this. Okay, so this is a parallel combination. So what is the R equivalent in this case? 1 by R1 plus 1 by R2 plus 1 by R2. Keep remember this is 1 by R equivalent. Okay, so R equivalent is basically you have the reciprocal. Okay, solve it and get the reciprocal. In this particular case, it will come out as what it is going to be R1, R2, R3, R1 to R2 plus R1, R2 plus R2 R. So this is the formula in this particular case, but yeah, that's the thing. In this case, if you said R equivalent, just add all of them, okay? This is the individual thing. Or that's the one thing to be discussed about. Now I can just give you one circuit. You have to calculate potential difference across position one, okay? This is R1 is equals to 2. This is R2. R3 is equals to 6. This is how much? 6 ohm I can say. Ohm I can say. So this R3 will come out as somewhere around 3 ohm. Okay? You can say this whole thing is connected with the resistance of this thing, which in the essence is again connected with R3, no, R5 and R4. Okay? The value of both of them is somewhere around 6 and 6. Okay? Just solve the R equivalent A of T. Okay? So this is the problem. Just try it and get me the answer. Okay? Can you just solve this and let me know the answer, please? Kiran, are you solving the problem?
Yes, sir.
Alright, you can just try this one and get me the answer. Okay?
One point seven ohms.
1.7 ohm. Okay. Before that, just let me know What is the configuration of this? Configuration mean to say just identify all the all the resistance which are in the parallel and the series. Okay. I will just give you example how you have to return me the combination. I'll just give you a small example for this one. Assume I'm having a circuit something like this. Let's assume there is a circuit something like this. A small circuit, not a big circuit. So I'm saying this is R2, this is R3, this is R1. Okay. So what you can say that, sir, this R1, 2 and 3 are in the parallel. So you will be writing R2 and R3, where R2 and R3 parallel. Okay. This is it, like how you have to represent. This R23, what it is going to represent? It will represent the equivalent resistance of R2 and R3. If I just tell you to replace this with a one resistor which is equivalent to this, basically if you remove this, if you replace this with this, it should not make any effect in your circuit. Okay? It's very simple thing. Like you want to have a 100 gram weight, but two ways are to have this: 20, 30, 50, right? In my current case, instead of two, I assume I have three cases. Okay. So if I replace these things with this, it won't make any difference, right? So same there also. In final, you can say that, sir, this R1 is in series with R23. Okay. So this is what kind of representation you have to perform in this particular problem. I'm not saying all cases you have to do. Okay. So yeah, this is about problem. Just tell me what is the configuration. Okay. Which part is in the series and which part is in the column parallel. Okay. So that's your task.
R2, R3 are in parallel, and the
Oh, okay.
equivalent resistance is in series with R1,
All right.
which is in parallel with R4,
Okay.
and its equivalent resistance is parallel with R.
R5. Okay. So I can say that Kirtana R2 and R3 is nothing but 6 into 3 by 9, right? This comes out as 2. Have you got the same? Equivalent of 2 and 3 is equals
Yes,
to 2.
yes,
Okay. Then R1, 2, 3. Basically, because both are in the series, this and this, so I can simply add both of them. So 2 plus 2, and so this comes out as 4. So here, I think everything is same, right? Then after this, we have this is in the parallel with this, so I can simply say that R1, 2, 3, and 4. This is nothing but equivalent of all these four resistors. So that is basically you already know. I have calculated this thing. I know this is in the parallel, so you can simply say that R1, 2, 3 into R2 divided by sum of 4. This is a way when two resistors are in the parallel. Now how it comes up is 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Okay. So this can be rewritten as R2 plus R1 divided by R12. So you can say that R equivalent comes out as multiplication of both divided by summation of both. Okay, so this is a way, instead of doing the whole thing, we can directly say that two resistance are there. So at the top, multiply both, at the bottom, add both of them. Okay? So this comes out as how much weighting? I can say this is 4 and 2, what is it? 6 I right? 6 divided by 6 summation, that is 10. So it comes out as somewhere around 22.4. Right? So this final thing is in the series with that. It's basically parallel with that thing. So R 1, 2, 3, 4, and 5. This is the cycle. 2.5 into 6 divided by summation of 8.5. Is it what you have got the equation?
yes, sir.
Yeah, like you must have taken it into the its fractional form, so it's also fine. Okay, okay, Ketan. So like the important topic is this part. If you are able good in this part, so you will be able to solve much of the portion from the textbook. Okay. Okay, I'll just give you another topic. One more thing is now, sometimes I forget to put the units, so be careful with the units. Okay, very important to be careful. Not in this chapter, every chapter whichever you solve them, never just ignore the part of the unit. So sometimes it plays a very important role. Yeah, so keep on this circuit for you. Just solve this and get me find equivalent circuit like equivalent resistance of circuit across A and B. Okay? This is what you do to figure out it. Try this statement.
So 14 by 9 ohm.
Now we should check it again once again, please. Um, I'm pretty sure we have made a lot of mistakes because the answer is not 14. It's a very small value. Start with the
So is it 1 ohm?
How much you got?
1 ohms.
Yeah, okay, now it's correct. It was 1 minute. Okay, so what was the mistake you did in the last case?
I took all of them as parallels.
Um, understood. All right, let's move to the next problem. Look, the chapter is more about a problem solving, so we'll go with the more of problem solving. Now it's an interesting problem statement. Okay? We have to do some assumption also. I'll just make it over here. This is a ladder problem. The same kind of problem we will be seeing when we're solving some circuits related to capacitors. Circuit is like this. One, the same ladder problem is, I think, present in the NCRT also. What it does want to say that the same thing is followed with infinite quantity. So this is going to the infinite, right? The same thing. Infinite quantity. And these are the two terms you are choosing A and calculate RAB. Okay. Basically, RAB is the potential resistance across the terminals A and B. That is what you have to calculate. Okay. So just try it and get the answer.
So the values.
The values, okay, this is 3. Okay, again, this is 3 units, 2 units, 3 units, 2 units, 3 units, and this is a 3. Okay. Look, I will just go to the new topic only after completing this circuit thing in a good manner. Okay. There are a lot of things to study in this chapter. Okay. So I can just do this, get me answer 3 more minutes. Okay.
Sir, is it 5n divided by 5 plus n?
How much you're getting, Kirtana?
5n divided by 5 plus n. N is a till infinity resistor.
No, it will be in an under root format. Okay. Alright. Should I give the solution for this one?
Yes, sir.
Okay. Keta, look, when I say this is going to infinite, can I say that look, this is the most case of the infinite, okay? So you just try to, if any way you need to figure out this kind of problem, always try to figure out a pattern. Okay, what is the which pattern is repeating? So if you see that, okay, which pattern is repeating? Can I say that this pattern is repeating?
Yes, sir.
So can I say that, Kirtana, if you just assume that what I'm saying, when I'm adding a lot of things to the infinity, assume I have a 1 crore rupee, right? If I subtract 1 rupee out of that 1 crore, will it make a lot of difference? Assume I have 1 crore coins, small coins, okay? I have put 1 crore coins in front of you. I just took 1 rupee coin. Will you able to figure out that I have taken 1 coin?
No, sir.
I will say no, right? Because it's a very huge amount. So can I say that, Kirtana, out of the lot of, assume that how this is this is the point from where the situation is repeating, right? Out of the whole circuit, I am just taking this part outside. But assume that the R equivalent of this thing is R. Okay? This is the value of this. Okay? Assume that the R equivalent of this thing is nothing but R is, okay? So what is the meaning of this? Can I say that Kirtana, this RS is nothing but equals to the resistance between this point and this point? Can I say this? Because what I'm trying to say that you have a big lot of big circuit, right? You have just taken a very small repeated pattern out of that thing, right? Only one pattern I'm taking. This is going till infinity. I have just taken out one pattern. Can I say this, Kirtana? That this thing is also equals to RS.
Yes, sir.
So Kirtana, can I just make this circuit into something like this? And this is the repeated pattern, like the which is the after. So what was the value of this? That was RS, right? Is this clear, Kirtana, till you?
Yes, sir.
And what is the RAB treatment which we have already done? So can you calculate this RAB? I can say these both are the parallel. So along these two terminals, R equivalent comes out as 2RS divided by RS plus 2. And the whole thing is in the series with this. So just add this. This is the R equivalent. But I know this thing that this R equivalent is nothing but RAB 2 times of RS divided by RS plus 2 is equal to 3. But you also know that this RAB is equal to RS. So just put the value equate both of them. RS is equals to 2 times of RS plus P divided by it is add here 2 plus RS the whole thing is 3. If you solve this equation, what you are going to get is RS is equals to 2 times of RS plus 6 times of 3RS. Okay, this is a limited will do this. So it will become RS squared plus 2 times of RS is equals to 2 times of RS plus so now I want to element 6 plus 6 plus 6 plus 3 R's. So what we have got here now from here, 3 R's is equals to 3 R's R's. So can you see this? We have got already equation. From this I can directly get the answer. Minus b basically 3 plus minus under root of this thing That comes out as 9 minus plus this is given to symmetry 4 AC. So it's exposure. So what you have got the great answer? So Petra, you can say that the equal resistance will be having two different values. What are those two different values? One is 3 by 3 minus under root 33. Another is 3 plus under root 31. So what do you think written out of these two are equal? Which is a valid value?
3 plus under root 33 divided by 2.
This is valid, right? Because resistance is always greater than equal to 3. Yeah, valid. Because it is less than 0. Alright, please, so that's all for today's class. Okay, I will end the session by now. Any doubt till there? Kirtan, do you have any doubt till this topic?
No,
No, right? Kirtan, just a second. I will just open NCERT and give you the summary. Kirtan, so can you see this screen? Look, in this, I told you to read out all this part. Okay, we have already covered all these things, so you can just go through this and read out. Just go through these examples. Okay, we have covered the topics, whatever required for these examples. Very good examples are these. The B part is basically dependent upon your grade 11th topic. So if you're good at it, so you will be able to get this answer. Solve all these examples, mobility and all. You just have to read it out. Look, read all this chapter. This is a very important chapter for the NEET. Okay, they can give you any line out of these topics. So just read each line carefully. Solve all the examples till this particular point. I think. Yeah. Okay. Now before this junction rule, okay, till here, Kirtana, you have to solve all the examples. Okay, till this point, example I think 3.2, solve all the examples and read topics before this Kirchhoff's law, I think. Yeah, before this Kirchhoff's law, you have to read and solve all the problems if there. So that is for the today's class and the homework for you.